Okay, so let's talk about predicting a double substitution reaction. And before we talk about the right way to do it, let's talk about the wrong way you're going to try to do it. Because students, there's always this pattern that pops up every semester. And when you see it, you're going to do it, and then you're not going to understand why it's wrong. So let's start with what you're inclined to do. We have iron 3 nitrate here reacting with sodium carbonate, and we want to predict the product of this double substitution reaction. And the instinct of students here is to say, let's swap these two. So let's make it Na2, NO3 taken 3 times, plus FeCO3, and I'm done. Now, why is this wrong? Well, first of all, let's go back. A double substitution reaction, we don't change oxidation states and we don't change charges. So on the left side here, this is iron and a +3. Well, if we look at the iron carbonate, FeCO3, this is iron +2. So off the bat, that's wrong because iron has changed its oxidation state. Now, let's look at sodium nitrate. Well, nitrate here is in a -1, so that puts a -3. There's 2 sodiums, which would put sodium in a 3/2 charge, which doesn't make sense. So this literal swapping is not how a double substitution reaction works. So how do you correctly predict what a double substitution reaction will do? Well, the way to do this is to think about it for what it is. It is literally just substituting either the cations and the anions. So to ensure that the charges work out, that you don't force the charges on the product side to make this just literally be a swapping of the iron and the sodium, the best approach to take is to write out the names of the reactants first. So in this case, we have iron 3, and I'm going to write out the name of the anion in a different color, nitrate. And I have sodium carbonate. So these are my reactants, iron 3 nitrate and sodium carbonate. If I want to know what the product is, either I can swap the anions or the cations. So personally, I like to swap the anions. So the product of this reaction is going to be iron 3 carbonate and sodium nitrate. So this is the name of my products, iron 3 carbonate and sodium nitrate. Now if I want to write the formulas, all I have to do is go back to my understanding on how to convert a name to a formula. So in the case of iron, I've got FeCO3, I've got a 3 charge on the iron, so that puts a 3 there, 2 charge on the carbonate, gives me Fa2CO3, and for the sodium nitrate, NaNO3. So this is the correct product based on what my reactants are. The trick here, and the ease, if you can get into it, of predicting double substitution reaction here, is just to write out the names and just swap either the anions, so just replace the iron and the sodium, or replace the anions, swap the nitrate and the carbonate, or replace the cations, swap the iron and the sodium. But in either case, it's much more effective for you to write the name out and go backwards. And the reason being is that particularly if you're at the chemistry 1 level, you may not have the intuition yet to remember what all the charges are when you start going to the formula. By writing out the name of the formula, it's going to keep track of the charges for you when you go backwards and make sure that you create a compound that makes physical sense in terms of the charges of the anions and the cations that are in the reaction. So this is the correct way, or a correct way, of predicting a double substitution reaction. Don't try to look at the formula and predict. There is a strong temptation just to swap the Fe and the Na2, and you can probably end up with compounds that don't make any physical sense. Instead, write out the names of the reactants, swap either the anions or the cations in the formulas, and then rederive what the product should be based on their names.